The third vector in our series of the most important vector quantities in physics is acceleration. Acceleration is a change in velocity. The unit of acceleration is the meter per second squared. Okay? So, like all things, all vectors are a magnitude and direction. In the case of acceleration, there's no special word for it, the magnitude. It's just acceleration. And then, as always, it comes with a direction. Let me give you an example. You may have learned in your class already that the acceleration due to Earth's gravity is 9.81 meters per second squared. That's the acceleration. Okay? I just gave you a magnitude. Remember that vectors are two pieces of information, a magnitude and a direction. So this is not a vector. This is a scalar because it's just a number with a unit. Okay? What would be a vector? Well, I'd have to add direction. So, as you probably know from life experience, the direction that the acceleration due to gravity points in is always towards the center of the Earth. So, from your day to day, that's basically down, right? So, a vector, the vector acceleration would be a magnitude, 9.81 meters per second squared, and a direction, and I'll just say simply down for now. Okay, that would be represented by an arrow. If this is the Earth, the acceleration due to gravity would be an arrow pointing down. The length of this arrow, the magnitude I should say, is 9.81 meters per second squared. That is, the length of the arrow is used to represent an acceleration. How does that work? Well, a 1-unit arrow is 1 meter per second squared. A 2-unit arrow is 2 meters per second squared. A 9.81 length arrow is 9.81 meters per second squared. That's how you can use length to represent things that aren't length. Finally, I want to show how all these important vectors are related. Acceleration is related to the velocity that we just learned about in the following way. The acceleration is the change in velocity over change in time. Notice how similar that is in the first video. Remember, the velocity was defined, I'll just put it here so you remember, change in displacement over change in time. See how similar they are? I want you to see how all these vectors are connected. So acceleration is change in velocity over change in time. In other words, if your velocity is changing, you are accelerating.